Good morning. Today is March 31, 2020. Once again, our subject for today is internal combustion engine. We will have a topic which is valve failures, and we have a subtopic for this which is valve burning. First, we will have a review on the valve assembly. So here we now have the cylinder head with a set of valve there, meaning in each cylinder we have two valves. So this is a set of valve where we can see the assembly attached to the cylinder head, and we will remove one to see what are the parts of the valve assembly. Okay, this time I already removed this valve, so I'll show you. So this is okay. By the way, let's determine first which is the intake and which is the exhaust. So as I've said in the previous video or videos, that the big one, or the bigger or the larger valve, is the intake valve, and the smaller one, of course, is the exhaust valve. Okay, let's try to remove this. Let's remove this. I have already removed the lock, so we can see the valve, and we can also see the valve seat. Here is the valve seat. Okay, I will make the camera closer so that you can see the valve seat. That's where the valve sits down or is having contact. Okay, and here it is. The valve seat contacts here. Okay, and we can see also some parts. Okay, which are the spring, the valve spring. We have the valve retainer, and then we have the valve locks or keepers, and we have the valve oil seal. Okay, the valve seal is inserted on the valve guide. All right, so let me insert the valve seal. Okay, this is the valve seal. Then we will just insert it here. Okay, I'll just push it and insert our valve. Okay, in this seat. This is the first one. Okay, so as you can see, the valve slides through that valve guide. Okay, as it slides and the valve is lubricated, oil will stay here. Okay, if the valve is already worn out in the guide and also the valve seal, then more oil will come inside. Okay, and is drawn or taken into the combustion chamber, and it is also burned. So to prevent oil or more oil from coming inside, so we have the valve seal. Okay, the purpose of the valve spring, okay, is to what? To hold the valve firmly into its seat. Okay, and the lock secures the valve to a retainer. Okay, so that it will not fall into the combustion chamber. Let me show you how the valve is being locked. Okay, we'll remove the valve and we can see, okay, the spring is there, okay, with the retainer, and it's assembled this way. And as you can see, there is a valve groove. Okay, this is the valve groove, right? Okay, that's the valve groove where the valve lock is placed. Okay, so two of those will be placed. All right, it's something like this, and it's something like this. Okay, you'll focus, and it holds the valve. See? Okay, so removing it. So remove the two retainers. Valve lock. Then we remove the retainer. All right. So that is the valve assembly. Okay. So again, we have the valve, we have the spring, we have the valve locks, valve keepers, or collets, as they call it in some other term. Then we have the valve retainer. Then we have the valve seal, okay, and the valve guide, okay. And the last one, we have the valve seat, okay. So I hope you learned about the valve assembly. Now that we know the valve assembly, let us proceed to our topic. But first, we will have to ask a question: why engine valves fail? Because our topic is valve failures. Okay, so why engine valves fail? Any valve will eventually wear out if driven enough miles. So we know that if we use our engine day by day and for longer use, then it will eventually wear out or be in trouble, because if you are using it, friction is always present when you use the engine, because the parts are moving and our valve also moves. So from the seat, it pops out or slides. So where does it wear out? It can wear out on the in the portion where the valve and the seat contacts, and the stem, which slides to and fro from the valve guide. So eventually it will be worn out. Okay? But many valves fail long before they should because of burning and breakage. So we have two reasons why engine valves fail. Can be a valve burning or a valve breakage. Okay, let us take up first what is valve burning. Okay, exhaust valves are the ones most likely to burn because they run hotter than the intakes. Okay, so we have a lead here to which valve are most likely to burn. As we know, exhaust valves, okay, permits, or this is the door which permits the burnt gases to go out, okay, during combustion, okay? So as we know, the intake valve is different because it admits intake air, or rather air and fuel mixture in gasoline, or air only in the diesel engine. So the intake valves, by that, the intake valves are cooled by the incoming air and fuel and consequently operate at about 800 degrees Fahrenheit. Exhaust valve, on the other hand, receive little such cooling and are blasted by the hot combustion gases as they exit through the exhaust port. Okay, so that's what I told you before, that hot combustion gases exit through the exhaust valve and passes on through that exhaust port. All right. Exhaust valves run at 1,200 to 1,350 degrees Fahrenheit. So it's very hot as compared to the intake valve, which makes them much more vulnerable to erosion and burning than intakes. The higher operating temperature requires a tougher alloy, so exhaust valves are usually made of stainless steel or have stainless steel heads. Okay, so exhaust valve burnt. Let us show some example. I will show you an example. So as you can see, that is the intake valve, and that is our exhaust valve. So exhaust valve burnt. What happened? So it lost, or it cracked. So we cannot see that part. Okay. The exhaust valve, the smaller of the two valves in this engine, has overheated and lost a chunk of metal. So it lost a chunk of metal. So the piece was already, detached from the exhaust valve, causing the cylinder to lose compression. Of course, air will escape there during compression stroke. So what is the result? It has a loose compression. Also note, the failed exhaust valve is the same color as the intake valve. So as you can see, they have the same color here. Supposed to be it has a different color, okay, which you will see later when I show you. So a good exhaust valve that is sealing and holding compression will usually have white or tan colored ash deposits on it. So what's the color? Okay, so as you can see, it should be like this color. Okay, that's a good exhaust valve. Okay, let's proceed. The intake and exhaust valves rely on physical contact with the valve seat and guide for cooling. About 75% of the combustion heat that is conducted away from the valve passes through the seat. So good seat contact is essential to prevent burning. Okay, what's this? It says that the intake and exhaust valves rely on physical contact with the valve seat and guide for cooling. Okay? So we have a contact for valve, the intake and exhaust valve contacts with the valve seat, and about 75% of that heat, okay, is conducted away from the valve and it passed through that seat. It passes the heat from the valve to the valve seat because it has its contact. Of course, the valve, the intake and exhaust valve, during combustion receives that heat And when the exhaust valve and intake valve contacts with the valve seat, that heat is being passed onto that seat, okay, at about what percent? 75%, okay? So, good seat contact is essential to prevent burning. So, if that contact is not good, okay, it will have burning or valve burning. Understood? Right. The remaining 25% of the heat is dissipated up through the valve stem and out through the guides. Okay? So we know that 75% of heat is passed on to the valve seat. So the remaining 25% of the heat is passed on or dissipated up through the valve stem, out through the guide. So the valve stem has a contact with the guide where it slides, so that the heat of the valve from that stem is passed on through the valve guide or guides. If the valve does not receive adequate cooling, it can overheat, burn, and fail. Okay? So fail meaning it will not work anymore. So again, remember, if the valve does not receive adequate cooling, it can overheat, burn, and fail. Let us go to the specifics or reasons why it does not receive adequate cooling. So one reason is a buildup of deposits on the valve face and seat can have an insulating effect that slows cooling and makes the valve run hot. Let us observe this drawing or illustration, rather picture, of our valve which has deposits on it. Okay, as you can see, we have a black sooted material here, which is carbon usually, or oil, which is burned. So this is a buildup of deposits on the valve face. Okay, so it hinders or obstructs the passage of heat or conduction of heat from the valve face to the valve seat. Okay, so it's either way, the deposits can build up on the valve face or on the valve seat. Okay, so that would make our valve run hot. Okay, remember that the valve should have an adequate cooling so that it will not be overheated. Take a look at this, another one. We have the exhaust valve. We have too much deposits here. Okay, also poor contact between valve and valve or seat rather makes the valve run hot if the seat is too narrow, non-concentric or concentric or off square. So this is the valve face. If it has a poor contact with the valve seat, because if it is narrow or non-concentric, it's not centered or off square, it's not fitted well. Okay, so it can have a poor contact that would also make our valve to run hot. If deposits build up in one spot or flake off in another, it can allow leaks that create hot spots on the valve and result in channeling, grooves eroded or burned into the valve. So, what's this? It says deposits build up in one spot let's say for example, it builds up here, okay? So what happens? It will make a leak. Why? Because it's having a poor contact on its seat. So it will allow leakage or hot combustion gases to leak, pass through the valves and make them hot. And if it flakes off in another, it will what? Have a channeling, okay? The grooves eroded or burned into the valve. It will make grooves, okay? So it will scar here or make a wound because it flakes off, all right? And it will allow leaks that create hot spots on the valve. Understood? What are other reasons for valve burning? Weak springs or insufficient valve lash can also prevent good valve-to-seat contact and allow excessive heat to build up in the valves. A loose seat or poorly fitted guide can also hinder heat transfer to the head and contribute to burning. All right, so weak springs. When it's weak, then it will not hold the valve firmly and it will not make a good valve-to-seat contact. So that's why it's also a reason why we will have valve burning, because it will have an inadequate cooling because the contact of the valve to seat is not good because of this weak spring. Also, if we have insufficient valve lash, by the way, valve lash is our valve adjustment that you have already known. So if the valve clearance is, too tight, so insufficient, meaning it's the clearance is too narrow or little, or we can say it's insufficient, so it will not have also, or it will also prevent a good valve to seat contact. Why? Because it's already pushing the valve away from the seat because of the sufficient valve lash or clearance. Okay? So it allows excessive heat to build up in the valves because it prevents good valve to seat contact. All right? Also, if you will think deeply, when the valves are away from the seat, it can also create a buildup or deposits on the valve face because it's not having that proper contact between the valve face and the valve seat. All right? Okay, another one. A loose seat or poorly fitted guide can also hinder heat transfer to the head and contribute to burning, right? So, a loose seat, remember that we have a 75% heat dissipation of a valve seat, okay? And a valve guide of 25% heat dissipation. So, if there is a problem in the valve seat, okay, specifically this is a loose seat, so it cannot transfer the heat to the cylinder head, okay? And also this one, if your guide is poorly fitted, it cannot transfer the heat very well to the head, which contributes to the burning of our valves. Let us see the springs here. The springs are here. Then we can see the difference. I will make it closer. We can see bad springs here. These two. And this is the good one. So you can see here 1, 2, 3. Can you spot the difference? So look at this. It's only 2, but this is 3. But the difference is here. These ones are much more farther apart than these. So that's the difference. And then this one, you can see the difference here. We have 3 coils which are near apart. Rather, they are neighboring with each other. And this is just 2. Okay, so we can now know if the springs are bad. Also, there is a measurement of the spring, if it is already like bent or not straight. Understood? All right. Let us proceed further. Okay, another problem for valve burning is our cooling system problems. So cooling problems in the engine itself can lead to valve sticking and burning if the operating temperature gets too high. So what are the reasons why there will be burning if there will be a cooling system problem or cooling problems? First, a low coolant. So we know if the coolant is not adequate or it's not enough, or if the level is low, then it cannot get the heat, excessive heat from the engine. So the temperature will get high. A defective thermostat, okay, it's also a reason why the engine will get high temperature. So we know that the operation of the thermostat, it opens during what? During engine is already, or rather the engine is already warmed up, then the thermostat will open. If the thermostat will be stuck close, even if the engine is warmed up already, then the coolant will not or cannot circulate well inside the engine, rather the water jacket, so it cannot get enough heat or the excess heat from the engine. Another one, a weak water pump. So if your pump is not forcing the coolant, or rather water, with additives, rather the coolant, if it's not being pumped well, then it cannot get heat. Another one, radiator obstruction can also lead to temperature increase. Why? Because, as we know, coolant from the top of the radiator, when it flows down, that is in the center of the radiator, the core, which the heat is being dissipated. So when it is obstructed, or if there is an obstruction there, the water cannot flow or cannot go to the lower tank of the radiator, so it cannot be cooled down. So temperature will get high. Another one, a defective cooling fan or fan switch, rather engine fan, can also lead to high temperatures. Why? Because it cannot cool the peripheral of the engine. And then there are other reasons. Okay, other reasons we will just take up later on. All right. So all of these reasons, specific reasons, this in turn makes the valve stems swell. They become big, which may cause them to gall or stick in their guides if there is not enough clearance. Why is there not enough clearance? Because the valve stem already has swollen. Okay? Becomes big. So that's why it's stuck into their guide. Okay? If the valve sticks open, it can burn or be destroyed if it smacks the piston. Right? So, if the valve sticks open, okay, imagine if it's open, therefore the burned gases will, overheat the valve, so it can be burned. If the valve sticks open, it can be also destroyed. Okay? How can the valve be destroyed if it sticks open? If it smacks the piston. Okay? So we know if the piston goes up and then the valve is stuck open, so it will strike the valve. So in that way, the valve will be destroyed by the piston. Okay? Okay. Let us see where the valve sticks. So here is our illustration. The valve sticks here with the valve guide. Because it becomes big or swollen, so it stuck here. So it may stuck close, it may stuck open. That's the worst thing there. If it stucks open, then it can be destroyed by the piston. And it's a reason for valve burning because the heat will be rushing to the valve. Okay, let's see the valve sticking. Okay, here. It's here. At the sides. Okay. Valves can also run hot because of elevated combustion temperatures. All right. So elevated combustion temperatures, meaning the combustion temperatures is higher because it's elevated. So what are the factors? Factors such as retarded ignition timing, detonation from too much compression or low octane fuel, or pre-ignition from hot spots caused by deposits in the combustion chamber, or too hot a spark plug can all play a role here. Likewise, exhaust restrictions such as clogged catalytic converter or crushed pipe can make the valves run hot. Okay, so we know some other reasons. These are additional reasons why valves run hot. Okay, because of elevated combustion temperatures coming from retarded ignition timing. When we say retarded ignition timing, the timing for ignition is delayed or late. because it's retard. Okay? Supposed to be, the ignition will take place, say for example, 5 degrees before top dead center, but it's delayed already. So, say, like 2 degrees before top dead center. Or, let's say, for example, we have a 10 degree angle before top dead center ignition timing, but the ignition timing that was given was 5 degrees before top dead center. So it was already delayed. Okay, now we have detonation. Detonation comes from what? Too much compression. Okay? How can we have too much compression? We can have too much compression if the space is already small in the combustion chamber. If we have deposits on it, like thick carbons covering the combustion chamber, the piston, the valves, then it can have too much compression because the space is already decreased. And also a low octane fuel. This is true with the gasoline engine, because we need a high octane of fuel to prevent detonation. Okay, detonation means if you have an octane which has low or which is low, then it's easy to detonate or be ignited easily, even if it's not yet time to be ignited. Likewise, with the pre-ignition, it says here pre. When we say pre, it's before ignition. The gasoline, rather the benzene, as you know it, ignites before its timing because of the hot spots caused by the deposits. If the combustion chamber is filled with, rather covered with deposits, then it creates hot spots. So that carbon can be red hot, and before the spark plug gives its spark, it's already been ignited by those hot spots. Okay? So here, exhaust restrictions, we have a clogged catalytic converter or a crushed pipe. So a crushed pipe also clogs the combustion gases that should exit the exhaust system. So when heat or those combustion gases did not exit fast in the exhaust system, so it is trapped there, making the valve to run hot. Understood? Okay, that ends our lecture on the valve burning. I hope you have understood the lecture. We will have a short quiz. Please answer the short quiz. 1 to 2, the question: what are the 2 reasons why valves fail? Then we have number 3 to 10, give specific troubles for valve burning. And once again, this is Teacher Lim. Thank you very much. Have a nice day to all of you and stay safe always.